Alright, welcome to the quadratic functions unit review for Algebra 2. So if we look at number 1, it says rewrite the function in complete factored form. Factored form should look like y is equal to a times x minus p times x minus q. And we know that p and q are the zeros of our function. And then the a value we can see from the original function is already 4. They always match. A is always A. So if I start, I know for sure it's going to be f of x is equal to 4 times something, and all I need to do is go to a graph and figure out what p and q are. So I have my graph over here. To save time, I already graphed it. And I need to find this point, and I need to find that point. So we're going to go to Menu, Analyze, and we're looking for the zeros. And there's one of them at 1.5. Menu, Analyze, 0. And there's my other one. So my two zeros are at -5, 0 and positive 1.50. So that means that my final function, if my zeros were at x equals -5 and positive 1.5, I have x plus 5 and x minus 1.5 as my two zeros, and that's my factored form. Explain how factors are related to zeros. Well, we talked about in class, and we just did it, that factors are opposites of the zeros, or you can think of it as zeros are the solutions of factors. Number 2, what are the zeros of the equation x plus 2 times x squared plus 2x minus 3? Well, we know that zeros are really just where we have x-intercepts. So all I have to do is, once again, go to my graph. So here's my new graph. And I can see that there's 3 of them. There's 1, 2, 3 points where I cross the x-axis. And I can use my calculator. Menu, Analyze Graph. Menu, Analyze Graph. And we can let the calculator find all of those zeros for us. Just going to move those around a little bit so we can see them. And I have zeros at -3, -2, and 1. So my zeros are at x equals -3, x equals -2, and x equals positive 1. Alright, moving on to number 3. Given that graph, write two equivalent functions. So we did this in class where we have 3 different forms. We have standard form, ax squared plus bx plus c. We have vertex form, a times x minus h squared plus k. And we have factored form, y equals a times x minus p times x minus q. So it says write it in 2 separate forms. So we're just going to pick a form to start in and then just convert it to the other one. The good news is I can see the vertex right there, which is at -1 and -5, 6, 7, -8. I can see a 0 at 1, 0, and I can see another 0 at -3, 0. So I'm going to start with vertex form. So we have y equals a times x plus 1 squared minus 8. I got that from here, h and k. And I need to find the a value. Well, we know that to find a, we just plug in some other point that we know. And I have 2 other points on the graph. So I have 0. I'm going to use this one, the right 0. So 0 is equal to a times 1 plus 1 squared minus 8. 0 is equal to 1 plus 1 is 2. 2 squared is 4, so I have 4a minus 8 If I move the 8 to the other side, I have 8 equals 4a, divided both sides by 4, and a is going to be 2. So that function then is y equals 2 times x plus 1 squared minus 8. That's vector or vertex form. And now that I've found a, once again, I know that a is always a. If I look at all three of these forms, a, and a, they're all the same. And I already know from my graph that I can see the two factors. So I'm going to use factored form to get my other function. So my other function is going to say y is equal to 2 times x and x. And what are my two zeros? I'm at -3 and +1. So that's going to be x plus 3x minus 1, because those are always going to be opposites of the actual factors, or of the zeros. Moving on to number 4. Given the function f of x is equal to 2x squared plus 12x plus 10, rewrite the function in vertex form. So once again, we know what vertex form is. It's y is equal to a times x minus h squared plus k. I can see a already, so I know it's going to be y is equal to 2 times something, so x minus something squared plus something else. So I'm going to go to my graph one more time. And there's my function, 2x squared plus 12x plus 10. And I need the vertex, because it wants me to be in vertex form. So to find the vertex, I can't quite see it. It's going to be just off the screen. But remember, we can kind of long press somewhere on the graph, or do control click, and we can grab the screen, kind of move it up, and now I can see the vertex. And then we're going to use the calculator to find that point. Menu, analyze graph. That is a minimum point, and we do our lower and upper bounds, and there's my minimum at -3, -8. So if my vertex is at -3, -8, then when I plug that in, I get x plus 3, and we're going to change that from a plus to a -8, and there's vertex form. Alright, and then does the function have a minimum or maximum, and what are the coordinates? Well, we know it's a minimum. We could see it from the graph that it was a minimum, and the vertex is also found, -3, -8. Number 5. Number 5 was a little bit tricky. So create two quadratic functions that have the same vertex and same x-intercepts. So the easiest way to probably start this is to start with a function in factored form. So start with creating a function that has two x-intercepts and then turn it into the other forms. If we look down here for f and g, it's telling us what form we need to be in. The first form is standard form, where we have ax squared, bx, and c. So I need to be in standard form for one of them, and my other one is vertex form, a x minus h squared plus k. So what I'm going to do, I'm going to start with the x-intercepts. So I'm going to pick my x-intercepts. They can be whatever you want. I'm going to pick mine to be -2 and +4. No particular reason for doing that. I just happen to choose -2 and +4. And I know that the factored form is going to be y is equal to x plus 2 and x minus 4. I'm going to make a 1 just to make my life easy. So that's factored form, but now I need to convert it to both standard and vertex. Well, to get into standard form, I'm just going to multiply this out. I'm going to use my Punnett square, x, 2, x, -4, got x squared, 2x, -4x, -8. So I get y is equal to x squared. I'm going to combine these like terms. Minus 2x minus 8. There's my standard form. So it's 1 x squared minus 2x plus negative 8. And then for vertex form, well, I'm just going to go to my calculator and I'm going to create a graph. And it's going to be that function, x squared minus 2x minus 8. And I'm going to let the calculator find the vertex for me. So I'm going to bring my graph up just a little bit. There's my vertex, menu, analyze graph, minimum. And that minimum is at 1, negative 9. So if my vertex is at 1, negative 9, then vertex form is going to be a, which is still 1, x minus 1 for h, plus negative 9 for k. And there's my two functions that are in different forms that have the same vertex and same x-intercept because they came from the same original function. Alright, and then number 6. The equation h equals negative 2 times x minus 5 squared plus 4 gives the height of a kangaroo jumping as a function of time. What is the maximum height the kangaroo reaches? Round your answer to the nearest tenth of a foot. So we know that maximum and minimum comes from the vertex, and we can see that we're already in vertex form. So I just need to identify the vertex, which is going to be at positive 5, positive 4, h and k, and the maximum is the y value. So my y value is 4, and we need to be more specific. The maximum is 4 feet. All right, number 7, the cross section of a large planter bowl can be modeled by the equation where x and y are measured in feet. Using the parabola below, label the key components used to find the width and the depth. So this is the depth of my bowl, which that looks like it's the vertex. So that's going to be a point, h and k. And these 2 points, those are going to be the top of my bowl, which if we think of it, those are going to be like the zeros. If we draw an imaginary line, like a horizon, that's going to be the top of my bowl. And that's how we're going to find the width. The width is going to be across it, and then the depth is that distance. So if we go to a graph, there's my function, x squared minus 12x plus 32. I have my bowl is basically just this little section right here. So I'm going to go to menu, analyze graph. I have a minimum again. Oops. So I have a minimum at 6, negative 4. And I have zeros at 4, 0, and 8, 0. So I'm going to label those points on my graph. So I have a point at 4, 0, a point at 8, 0, and a minimum at 6, negative 4. So determine the width of the planter bowl. Well, the width is the distance from 4, 0 to 8, 0. So the width is just 8 take away 4, which is 4 feet. The depth of the bowl, depth is how tall it is, and that is the distance from the x-intercept, so from this line here down to the bottom of the bowl, which that is the y value of my vertex, which is negative 4. So it's at the minimum, which is at y equals negative 4. So the depth of my bowl is 4 feet. Alright, and then moving on. So number 8. Graph the function y equals x squared plus 2x minus 8 using line of symmetry. The vertex x and y intercepts. Label the key points. So we're going to start with the line of symmetry. We know the equation for the line of symmetry is x equals negative b over 2a. My b value is 2, so it's negative 2 over 2 times a, which is 1. Which gives me negative 2 over 2. So the line of symmetry is that x equals negative 1. My vertex, I know that my line of symmetry is the x value of my vertex. So the y value of my vertex is just plugging in my x value. So it's y equals negative 1 squared plus 2 times negative 1 minus 8. This is going to be 1 take away 2 minus 8. This is going to be negative 9. So my vertex is at negative 1, negative 9. And then my x-intercepts, I'm actually just going to go to my graph for the x-intercepts. There's my function, x squared plus 2x minus 8. My x-intercepts are at negative 4 and positive 2. And so I can graph everything. My vertex is at negative 1 and negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And my zeros at negative 4 and positive 2. And there's my graph. Number 9, it's actually the exact same function if we look at it. That just happened to work out for this problem, but we need to make sure we understand how to do it. Does the graph open up or down? Well, because a is greater than 0, we open up. What is the y-intercept? Well, the y-intercept is when x is equal to 0. So that's 0 squared plus 2 times 0 minus 8. Those are going to cancel out, and we're left with y equals negative 8. What is the vertex? We already found the vertex. If this was a different problem, we would just go to the graph to find the vertex. Or we could do the line of symmetry stuff like we did on the last one. Does the vertex represent a minimum or maximum? Since the graph opens up, it is a minimum. And that minimum is at y equals negative 9. Identify, so I didn't read, it's just a minimum. Identify the value of the minimum. Y equals negative 9 is our minimum value. Alright, and then F says to graph the function, or graph the equation again. Well, we already graphed this one earlier, so we're just going to graph it again. We have a 0 at 2. We have a 0 at negative 4. We have a vertex at negative 1, negative 9. And we actually know one more thing about this graph. We know that it crosses the y-axis at negative 8. And there's our graph. 10. We're going to compare the two graphs, f and g, and we're going to mark anything that's going on. So we're comparing g to f. So f is our original function, g is the new function. So compared to f, the graph of g is, so if we look from f to g, g is narrower. And then it's also shifted. This one started at 0, 0. And this one is at negative 2, negative 5. So our entire g graph has been shifted down, and it's been shifted left. Hasn't been reflected. And then generate the new equation of g using the transformations described above. So the two easy ones are going to be these two values. This looks just like vertex form. So if it's f of x plus something, how much did x change? Well, it changed -2. So remember, in vertex form, the inside is always the opposite of the vertex, so it's x plus 2. And then outside, we move down 5, so we have -5. And then the kind of tricky part is going to be this a value. Well, what I'm going to do is look at my parent function, because I know it's stretched, I just don't know how much. This original graph, to get from this point to the next point over. So to go over 1, I had to go up 1. On my new graph, G, to go over 1, to get to my actual graph, and it's really hard to read on here, but I have to go up to that point right there, which means I had to go up 1, 2, 3 units. So I went over the same amount. I went over 1, and on F I went up 1. And then for G I went over 1, but I had to go up 3. So my G graph is 3 times taller than my F graph. So that means my A value is 3 because it's being stretched by a factor of 3. All right. 11. 4 bowls with the same height are constructed using quadratic equations as their shapes. Put the bowls in order from narrowest to widest. Well, narrowest means the largest A value, so big A, and widest, small a. Narrowest is going to be stretched the most, widest is going to be compressed the most. So my biggest stretch is 9x squared, so that's D. My next biggest stretch is bowl 2, because it's 3x squared. Then my next biggest is 3/4, and then my last biggest is 1/3. 12. A person tosses a water balloon from the roof of a building. The situation is represented by the function. State the domain in the range in the context of the situation. So we're throwing a water balloon. We talked about in class in real life situations. We only care about what's happening after something starts moving. So here's my function, -2x squared plus 11x plus 5, and we can see the graph, but everything on the left side, like over in this area, that's negative time. We don't care about that. We only care about, for our domain, we care about when we start throwing the ball, which is right here at 0, and we care about when it comes down and hits the ground, because once it hits the ground, we don't care anymore because now it's not moving. So what we need to do is find out that point right there. So menu, analyze graph, that's a 0, and that's at 5.92 seconds. So my domain goes from 0 to 5.92, and they both get brackets. My range, same idea, is the y values. Well, I don't care about my graph once it hits the ground, so I'm going to stop at 0, and then I want to know what this highest point is right there, because we're talking about y, so the highest it ever goes is that point. So again, menu, analyze graph, this time it's a maximum, and that's at 20.1 seconds, or 20.1 feet. So my range goes from 0 to 20.1. So my domain goes from 0 to 5.92 seconds because the 0 is where it starts being tossed, and it takes 5.9 seconds for it to land. And then my range goes from 0 feet, because that's the ground, and it starts at 20 feet in the air. 13. Given the graph of a quadratic, state the domain and range. This one is just a regular graph. There's no context behind it. So we're just going to simply look at the graph and state the domain and the range. Domain is x values, range is y values. We know that for any quadratic not in a specific situation, the domain is always going to be negative infinity to infinity, all real numbers. And then the range we can see is the possible y values. Well, I don't have a minimum value because it goes down forever. So it goes from negative infinity and it stops at this highest point, which is at 1. So the range of my graph is negative infinity to 1. Alright, and then almost done. The height of a ball t seconds after being thrown is modeled by that function. Describe in words the meaning of h of 3 in this context. Well, so we know that h of t represents the height of the ball at some time. They told us that. The height h of a ball t seconds after being thrown. So the height t seconds after being thrown, that's what the function gives us. So specifically, h of 3 then would be the height of the ball 3 seconds after being thrown. That's it. What is the maximum height of the ball? Well, the maximum height is the y value of the vertex. So we're going to go to the graph. We're going to draw that graph, negative 2.5x squared plus 9.8x plus 2, and we're going to find that vertex. So menu, analyze graph, it is a maximum. And we want the y value of the vertex. So the vertex itself is at 1.96 and 11.604, or just 11.6. So what is the maximum height of the ball? Well, the maximum height of the ball is the y value of the vertex. So the ball reaches a maximum height of 11.6 meters. Don't forget your units. And that is it for the review for the quadratic functions unit.